Right, so now we're on worksheet 11.8. I like this font. Okay, use the appropriate trigonomic ratio, that is sin, cos, or tan, to solve the problems in this worksheet. So, to find the distance across this lake, the surveyor has to measure AC. So what is AC? So we've got A, B, and C. So AC, he's got to measure that to be 150 meters, and angle BAC, so BAC, which means that the angle's there, is 35. So if you want to draw it, you can put in your 150 here, and you can say that's 35. Calculate the distance D there across the lake to the nearest meter. So we know what this is. We know that this is 150 meters, and we know that this is 35 degrees. So this is going to be our adjacent. This is going to be our opposite. So we know that that's going to be tan, okay? So because it's O over 8. So our opposite is D, that goes on the top, and our bottom one here is A, is, 150 meters. So there you go. So we go 150 times tan, 35. Put that in your calculator, equals, and bring it to the nearest whole number and the nearest meter. Don't forget to put the meter on there. Number 2, a plane is flying at an angle of 12 degrees to the horizontal. So 12 degrees there, you can see. How far in X meters will the plane have to fly to increase its altitude by 300 meters? So we know that that's 300. So we know we're looking at that, and we know that we've got the angle. How many meters does it have to go? So we say, okay, well, we're looking at sin, because we've got the opposite, which is that will be your opposite, and your hypotenuse will be here. Okay, so now we're going 300 over x. So because the x is on the bottom, we have to divide. We go 300 divided by sin 12. Calculator. And that will give us how many meters he has to fly. Make sure you show all your working out. Right, the pilot of a plane with engine trouble 1.5 kilometers above the ground, oh heck, sees a landing strip 2.1 kilometers away. There he is. He sees a landing strip there. It's 2.1 kilometers. What angle to the horizontal, so here, must she descend to reach the landing strip? Answer to the nearest degree. Now, we know that this angle is equal to that angle. So we're going to pretend that the angle is here. If the angle is here, this becomes adjacent, and this becomes opposite. So we're going to do tan, and we're going to go O over A. So our opposite, if our angle's here, will be 1.5 over 2.1. And then we're going to go tan dash 1, because we need to get a degrees, 1.5 divided by 2.1. And write down your answer, and then bring it to the nearest whole number, nearest degree, and put your degree sign on there. Right, to make sure water and waste are not trapped in a factory drain pipe, the drain pipes are laid so that for every 6 meters of pipe, there is a vertical drop of 20 centimeters. So 20 centimeters is down here. The pipe is 6 meters here. What angle does the pipe make to the horizontal? So they want to know this here. Answer to the nearest degree. Now, before we can even carry on, we've got to look at something. This is in centimeters. This is in meters. Okay, so we've got to make them the same. So we go sin O over H. We put 20 over 600. We make them both into centimeters. So our opposite over our hypotenuse, 20 over 600. Remember, they want to know the degree. So we go sin dash 1, 20 divided by 600. Get our answer. And then we round it to the nearest degree, because that's what it says. And we put the degree sign. Okay, good one.